2020 Exam 2, Question 3, Networks and Decision Making. Okay, so we've got this graph here and we've got all these training programs. All of them must start at exercise station S, which is here. And it says, what is the shortest distance covered by training program 1? So training program 1 up here, so it says you must run to exercise O. So it's the shortest path between those. Just do a trial and error. Don't need to spend ages on the Dijkstra's or anything or whatever. This distance is 3.3, just doing that top line. That was apparently a popular answer, but not the correct answer. If you go through the middle here, you get 1.8. So that's very similar to this 1.8 here. I'm just going to rewrite that because that's messy. 1.8. And then you've got to compare, like, you've got this 1.5 here. Can you get from this point to O in less than 1.5? If you do this bit, it's 1.6, so no. If you did this bit, it's 1.4. So 1.8 plus 1.4 is 3.2. So it looks like we got a winner here. So we can just say bye-bye to you. Don't care about you. We've got a 3.2. And there's not many other possible paths we can compare here. So this part down here, that's 0.4 plus 1.4 is 1.8 compared to this 0.8. Well, 1.8, 0.8, no good. And you can see very quickly when you're coming down here, you're already 2.2. So already 3 by the time you get there. So it's not going to get lower than 3.2. If you try and go here, it's going to be even worse. You're going to add 1.2 or a 1.8 here. So there's no way going down that bottom path through SRQ that you're going to get better than 3.2. So the answer is 3.2 when the screen is behaving itself. 3.2 kilometers. I don't think they got fussy about the unit, but who knows. 3.3 was the common mistake. Now, next one, we're going to be looking at training path number 2, training program number 2. So what is the mathematical term for 2? So what you're doing with 2 is you're going along every track just once. So that when you're just talking about the tracks, that's the edges. So that means it's Euler, but it's Euler trail. Euler trail. All right. So remember Euler trail, Hamiltonian path, or Hamilton path. Depends on your point of view. I was like Eulerian. Make sure you've got Euler trail, Hamiltonian path, and then you've got your cycles and your circuits, and you've got them all sorted out so you don't make that mistake of putting cycle with the wrong one or circuit with the wrong one or trail or path. That should be in your notes. Quick reference just to reassure yourself. All right. Before I ramble on, let's look at the next one. Which exercise station would training program 2 finish? Now remember, you're starting at S, and that's got a degree of 3. So basically, remember, with the Euler trail, you can have 0, because an Euler circuit is also an Euler trail, technically, but you're going to look for another odd vertex. So this is 2. This is 4, this is 4, this is 2, this is 2, this is 2, this is 4, this is 4. What do you know? This one's 3. So remember, if you start on one of the odd ones, you're going to finish on the other odd one. And so we have to start on S for start, so we got to finish with a P. All right, this one was a little bit trial and error when I tried this, so I'll just show you some trial and error. So we must visit every exercise station and return to S. But we need to do that in the minimum distance. One track will need to be repeated. All right, so it's not asking you to find the minimum distance. It's just saying if you do the minimum distance, you've got to repeat one track. I think they're a bit mean in the comments on this. They said many students were unable to demonstrate an understanding of the requirements of this question. I think it was just that they just couldn't figure it out. And I'll show you why. Because like you got to start at S, right? Because all starting at S, so you got to get S back to S, and so that can, going like that, and then repeating a lot here, aren't I? No, let's try that. Let's try that another way. Let's try going this way, this way, this way, this. Oh, that's not too bad. But then I've got to get to T, and I've got to get back to S. So that actually looks pretty good. So you've actually gone between S and T. Now think about this. Any other path you're doing, that's the lowest number to go out and back again from. Okay, so I don't know if you can do, if you did that, that, you'd be repeating R. And there might be ways to repeat M, but the lowest value, if you're going back out and doing R or T or M, the lowest value to do that is with T. So if you're looking for the minimum distance, it's quite likely that the best one to repeat is going between S and T because it's the lowest value there. Yeah, not the nicest question.